In this lecture, we will discuss the OSI model. In my previous lectures on CCNA program as well as the A+ certification program, I have introduced you to the OSI model. Today, we will go a little bit in depth into how the OSI model works. This is a very important concept to understand in networking. First, we're going to look at protocols. So what is a protocol? A protocol is a set of rules to ensure successful host-to-host communication. A communication protocols define or establish the rules, syntax, semantics, and synchronization of communication and possible error recovery methods. So for example, even when you're speaking to someone, a human, you have to define a set of rules. If I decided to speak in Sinhala, but someone else decided to speak in English, we have a breakdown in communication. So we have to establish a common language. So I can't speak in Sinhala and the other person cannot speak in English if either parties don't understand the language. However, if we set a common set of rules saying let's speak only in English, in that way we have basically defined or established a set of rules for common communication. The computers work similar to that, except in computers, that common language or common set of rules between two parties or two hosts or multiple hosts is defined as a protocol. So let's look at the rules of establishment. So individuals must use established rules or agreements to govern the conversation. As we have seen in our previous slide, you can have two different languages that either parties don't understand to communicate. So two individuals or two parties would have to establish a common language. In most cases, it would be English in 2022 because that's one of the most common languages being used around the world. It is also important that we have a proper formatting of communication. Let's say you are writing an email to the other party in English. And on the bottom of your screen, you have two messages, but the first message is difficult to read because it is formatted, it is not formatted properly, it is improperly formatted. But the second message is properly formatted and easy to read. So even though the first message has the same text as the second message, the formatting of the first message is incoherent compared to the first message. So the same principle applies to computers or host or networking devices. Not only we need to establish a common language to communicate. In this situation, it would be the digital languages like 0101 as opposed to an analog language. But it also needs to be properly formatted. So it has to have proper syntax and proper formatting in order for those hosts to communicate. So network protocols can be viewed as this. So we have the network protocols define a common set of rules, as I mentioned in my previous slide. And the overall picture that you need to get into your head for understanding of how protocols and suites work is that these protocols or common set of rules can be implemented in the software, the hardware, or both. So it could be a software defined protocol, it could be a hardware defined protocol, or both. In most cases, it is going to be both or mostly associated with software. Protocols have their own set of functions, formats, and rules, as I mentioned before. On the right hand side, we have a table that actually describes some protocol types and descriptions. Network communications protocols enable two or more devices to communicate over one or more networks. Network security protocols secure data to provide authentication, data integrity, and data encryption. Routing protocols enable routers to exchange route information, compare path information, and select best path. Device discovery protocols used for automatic detection of devices or services. So these are some common types of network protocols in use. Network protocol functions includes devices to use agreed upon protocols to communicate, and protocols may have one or more functions. So for example, functions of addressing, reliability, flow control, sequencing, error detection, and application interface. So in a network protocol functions, these are very important key functions that needed to be a part of that protocol. So if you are defining any network protocols, they should compose of these type of functions: the addressing, reliability, flow control, etc., etc. So in a network protocol function, the addressing will identify the sender and the receiver. Reliability provide guaranteed delivery, such as the TCP connections. Those are the guaranteed delivery, as opposed to UDP, which doesn't give you the guaranteed delivery. Flow control ensure the data flows at an efficient rate, and the sequencing uniquely labels each transmit segment of data. Error detection determines if the data becomes corrupted during transmission, and application interface would allow the process-to-process communication between network applications. If you would like to go a little bit in depth into how each of these functions work, please go and check my CCNA 1 and CCNA 2 and CCNA 3 lecture series that I have already posted on my YouTube channel. Then I have in there I have go into depth of these different functions associated with network protocols. Protocols interaction. So networks require use of several protocols. You can't just use one single protocol to communicate within your network, because that is not going to work. So each protocol has its own function and format, and they have to work with each other. For example, the protocols such as the Hypertext Transfer Protocol, HTTP, that governs the way a web server and a web client interact and define content and format, and the Transmission Control Protocol, TCP, manages the individual conversations, provide guaranteed delivery, and manages flow control, because TCP is a guaranteed delivery protocol. It's a connection-oriented protocol. The Internet Protocol, also known as IP, delivers messages globally from the sender to the receiver, while the Ethernet Protocol delivers messages from the network interface card to another network interface card on the same Ethernet local area network LAN using the MAC addresses, right? But all of these items has to work together if you were to access a web host from your computer. So that's why the protocols has to work together in order for your network systems to operate correctly. Again, I have discussed these things in much more detail in my CCNA lectures. This is just a broad overview so that you have a better understanding about how individual protocols operate, so that you have a proper background to understand the OSI model. Protocol suites. So we're going to talk about network protocol suites and how they are important to communication within a network. Protocols must be able to work with other protocols, and this is where the protocol suites come into play. Protocol suites include a group of interrelated protocols necessary to perform a communication function, set of rules that work together to help solve a problem, and the protocols are viewed in terms of layers in those suites. There are higher layers and we also have lower layers defined on that stack of different layers. So this is why you may hear the term TCP IP stack or OSI stack interchangeably with the OSI model or TCP IP model. The higher layers and lower layers are basically a general division of layers, where the lower layers concerns with moving data and providing services to upper layers. Evolution of protocol suites. There are several protocol suites. Those includes the Internet Protocol Suite or TCP/IP, which is commonly utilized by the Windows operating systems as their primary base for defining network communication, which is the most common protocol suites and maintained by the Internet Engineering Task Force, also known as IETF. The other one is the Open Systems Interconnection, which is also a common protocol, commonly known as the OSI model. It is developed by the International Organization for Standardization, also known as ISO, and the International Telecommunication Union, or also commonly known as ITU. So these are the most commonly used protocols in network communication: TCP/IP and OSI. The other protocol suites also includes Apple Talk, which is a proprietary suite released by Apple Inc., and the Novel NetWare, which is a proprietary suite developed by the Novel Inc. The commonly used, however, as I mentioned before, is the TCP/IP model and the OSI model. And in this lecture, we will be mostly focusing on the OSI model, and then we will go into TCP/IP model maybe in a different lecture. On the right-hand side, you have a diagram that is taken out from the Cisco NetAcad program that shows a way that how TCP/IP model works, as well as the how the OSI model relate to it. And we will go into depth of how these layers work with respect to OSI model in the next few slides. Reference models. The benefits of using a layered model. Complex concepts such as how a network operates can be difficult to explain and understand. For this reason, a layered model is used, because then we can summarize the complex concepts of how we communicate across a network. Two layered models describe network operations that are commonly used, as I mentioned before, are the OSI model and the TCP/IP model. So on the on the left-hand side, we have a comparison between the OSI model and the TCP/IP model. On the OSI model, we have 7 layers from bottom to the top, starting with physical layer, then data link, network, transport, session, presentation, and application. On the TCP/IP model, we have 4 layers, starting with network address or network layer, internet layer, transport layer, and an application layer. So these are 2 different models, but does the same thing when it's come to the point communication. So as I mentioned before, it doesn't matter whether the device is actually based on the OSI model or the TCP/IP model. This is just a way for us to understand how network communication work. So it doesn't matter how the device is specifically built. At the end of the day, what they are doing is they're going to be using these different protocol that associated with these different layers to communicate with each other. So it doesn't really matter whether a device is based on OSI model or the TCP/IP model, because as long as they are using this standardized method of communication, these protocols, they should work. So keep that in mind. The reason why we have these type of models, so that we can communicate the concept, complex concepts such as how the network operates easily, so that we can define these things properly, so we can build our network infrastructure. These are the benefits of using a layered model. Assist in protocol design, because protocols that operates at a specific layer have defined information that they act upon, and a defined interface to their layers above and below. Foster competition, because products from different vendors now can work together because they are following either OSI model or TCP/IP model, and they are following this particular type of methodologies, so that different competitors' devices can work together. For example, I can buy a Cisco switch, and I can also buy a D-Link router, and that D-Link router would be able to interoperate with the Cisco switch, no problem. So this would also prevent technology or capability changes in one layer from affecting the layers above and below because of the interoperability, and provides a common language to describe networking functions and capabilities across a broad range of devices, spectrums, manufacturers, etc., etc. So let's look at the OSI reference model, because that's our primary focus today. So OSI model OSI model have 7 layers. From bottom to the top, we start with physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. When it's come to the point reading layered models, we typically read it from the bottom to the top. That's the way that we typically set things up. But there is no rule whether you start from bottom to the top or top to the bottom. In fact, when you go through the next few slides, we actually going from the top to the bottom, but we typically define from the bottom to the top. The physical layer describes the means to activate, maintain, and deactivate physical connections. Data link layer describes the methods for exchanging data frames over a common media. The network layer provides services to exchange the individual pieces of data over the network. The transport layer defines services to segment, transfer, and reassemble the data for individual communications. The sessions layer provides services to the presentation layer and to manage data exchange. The presentation layer it provides for communication, representation of the data transfer between the application layer and the layer services. And then the application layer contains protocols used for process-to-process communications. And we're going to deep dive into these layers in the next few slides. So here's the OSI model. And it is a 7-layer conceptual model, as I mentioned before, and it is developed by the International Organization for Standardization, ISO, in the 1984. But the actual development of this particular model started in the 1970s, but it got finalized in the 1984. And it describes standards for inter-computer communication, as I mentioned before, and helps you to break down network functions, especially for troubleshooting, but as well as for developing the network infrastructure and equipment. And it creates standards for equipment manufacturing, as I mentioned before, and allow vendors to focus in specialized areas of the network, so that different vendors may be able to specialize their organization's products into different layers. Like, for example, Intel may produce physical Intel NIC cards, while organizations such as Microsoft using application and presentation and sessions to develop their products based on those layers, upper layers, because reason for that is Microsoft have no interest in building, as of 2022, a network interface card. So that allow vendors to focus on their own specialized areas, but the Microsoft software that is being built based on the top 3 layers can interoperate with the network interface card that is a physical layer product developed by Intel. So the Microsoft will allow this type of layered model will allow those kind of 2 organizations to interact with each other's products. So first we're going to start with the layer 7, which is the application layer. The application layer is the very top layer of the stack, and it interfaces with the application. For example, it could use protocols such as HTTP, FTP, SSH, etc. And you can use an application such as a web browser to interact with HTTP, HTTPS, or you can use a SSH application where it will be using those SSH protocols to interact with the network devices. And it provides network access to applications, and it is the most upper layer of the OSI model. The functions of the application layers includes the network virtual terminal, the FTAM file transfer access and management, mail services, and directory services. The next layer is the layer number 6, which is the presentation layer. And it is used for data formatting such as HTML format itself, the JPEG format, the MP3 format. Those are all part of the presentation layer because it is actually formatting the data itself. And it allows encryption services such as online banking or encrypting important documents. And it also allows things like compression because these are all part of the that presentation layer right below the application layer. The functions of the presentation layers can be summarized as the translation, for example, ASCII translations, and encryption and decryption, as I mentioned, that allow the data encryption, translate the data into another format or a code. The encrypted data is known as the ciphertext, and the decrypted data is known as the plain text. So you will hear terms plain text a lot, like a plain text document being encrypted, but once it gets encrypted using the presentation layer, it is known as a ciphertext. A key value is used in encryption as well as the decrypting data, and that would happen in this particular layer. In terms of compression, it reduces the number of bits that need to be transmitted across a network. So the data compression include things like zipping files or some kind of a specialized compression methodology that or process that can be used in this particular presentation layer in order to make the data more manageable in terms of transmission, right? So the smaller the data size is better for transmission. The next layer is a layer number 5, which is a session layer that controls dialogues between computers and start and end sessions and logically keeps sessions separate. So we can describe those functions in terms of session establishment, maintenance, and termination. That is the control part of it. And the layer allows the two processes to establish, use, and terminate a connection. In terms of synchronization, this layer allows a process to add checkpoints which are considered synchronization points into data. These synchronization points help to identify the error so that the data is resynchronized properly and ends of the messages are not cut prematurely and data loss is avoided. So especially things like, especially in the TCP protocols, but also in UDP protocols, the synchronization is very important that allow the process to add checkpoints, which I have described in my CCNA lectures in depth, how that works. It also do the dialog controller. It will act like a dialog controller, which the session layer allows two systems to start communication with each other in half duplex or full duplex mode. So when it's come to the point setting up your network configurations, when you are setting up your half duplex or full duplex systems, in modern day in 2022, you should only be setting up full duplex because I don't know why anybody needs half duplex. That duplexing actually happened at the session layer. So the next layer is the layer number 4, which is the transport layer. Transport layer describes how the data is sent. So that is where the TCP or UDP picking happens. So whether it's going to be reliable transport, which is going to be the TCP transport, or unreliable transport, which is going to be the UDP transport. Again, I have described extensively how those works in both my A+ certification program lectures as well as my CCNA lectures. You can go ahead and check those out. And it defines a well-known services and port numbers that associated with firewalls. So like what that means is basically not only we know whether we're going to be using TCP or UDP or both to communicate in that transport layer, we also defining port numbers. For example, if you access a website using HTTP, that would be using port number 80 because that is a well-defined port used for the communication of HTTP data. If you are accessing a website such as sanuja.com, which is using port 443, that is using HTTPS and it is using port 443 because the transport layer have defined the HTTPS secure communication to port number 443. So that's where this happened, the layer number 4, which is the transport. And it also controls the size and the rate of message. In other words, the segmentation happens at the transport layer. A little bit in depth of functions of the transport layer. So segmentation and reassembly. So this layer accepts the message from the session layer, which is the layer above right here, and breaks the message into smaller units that called segments. And each of these segments has a header associated with it. The transport layer at the destination station reassemble these messages as those segments being received on the destination device. The service point addressing also happen at the transport layer. So in order to deliver these messages to the correct process, the transport layer header includes a type of address called the service point address or port address. And thus, by specifying this address, the transport layer makes sure that the message is delivered to the correct process. So the service point addressing and the port numbers, what they are doing is both port number and the service point addressing is making sure that the delivery is done to the correct process. The next layer is a layer 3, which is the network layer, which is right below the transport layer. It is also known by the term logical layer. The reason for that is it is where the logical addressing happen. The logical addressing is the addressing that we commonly define as the IP addressing schemes. So that's where the IPv4 and IPv6 addressing coming into play. So that all happen in the network layer, and it finds the best path to the destination, and it is responsible for routing. So routing happens in terms of how the router, if you have a router on your network, that router is basically operating at the network layer level. The functions of the network layer can be defined, therefore the routing, which is the network layer protocols determine which route is suitable from source to destination. This function of the network layer is known as the routing part of that network layer. And it is also responsible for logical addressing, which is in order to identify each device on inter-network uniquely. The network layer defines an addressing scheme. The sender and receiver's IP addresses are placed in the header of that frame by the network layer. Such an address distinguish each device uniquely and universally. For example, if you access a sanuja.com website or any website, the IP address associated with that will be handled by the network layer. So the network layer is also known as a logical layer because that's where the IP addressing schemes come into play. And again, I have described how IPv4 and IPv6 works both in my CCNA lecture series as well as my A+ certification program lecture series. And you can go ahead and watch those on my YouTube channel if you want to have a comprehensive understanding about how the logical addressing schemes work. So the next layer is a layer 2, which is the data link layer, which is known as the physical addressing layer. The reason why we call this is a physical addressing layer, the data link layer, is because that's where the MAC addressing happen. And the MAC addresses are related to the physical network interface ports because they are typically hard coded into those network interfaces on your device. So that's why we call it a physical addressing, and it ensures data is error free. And this is where the switching happen in your network. So if you have network switches, which are oftentimes defined as layer 2 switches, this is where it is going to happen. So the layer 3, there are layer 3 switches we have described that in network engineering and network technical lectures in CCNA in my previous videos. Those layer 3 switches are operating at layer 3 level, just like it defined layer 3 switches, network level. So layer 3 switches are closer to that of a router than that of a switch, even though we call it a switch. The typical switches, typical network switches are actually operating at layer 2, which is a data link layer. So keep that in mind. the routing happen in network layer, switching happen in data link layer. The switches that are defined as layer 3 switches, however, operate in the network layer because they are specifically designed to operate at a higher level, higher layer, right? So that's why. So typically most switches operate at the layer 2 or data link layer. So the functions of this type of data link layers include framing. So the framing is a function of the data link layer. It provides a way for a sender to transmit a set of bits that are meaningful to the receiver. This can be accomplished by attaching special bit patterns to the beginning and the end of the frame. It is responsible for physical addressing. So after creating the frames, the data link layer adds physical addresses. These are known as the MAC addresses of the sender and or the receiver in the header of each frame, and that's how it would identify the sender and the receiver. And in an internal LAN environment where device-to-device communication occurs at the MAC level, at the MAC address level. So you don't even need the IP address to communicate between devices within a local area network. You can simply use the MAC addresses to communicate within the local area network because it is part of that frame that identifies the sender and receiver. The data link layer also does the error control. It provides a mechanism of error control in which it detects and retransmits damage or lost frames. And it also responsible for flow control, where the data rate must be constant on both sides, else the data may get corrupted or get clash with each other. So the flow control coordinates the amount of data that can be sent before receiving acknowledgement. So basically flow control, where two or multiple devices communicating against each other, happens at the data link layer. And why flow control is important? Because it prevents data corruption and it prevents the transmission of multiple data at the same time, causing those streams to crash with each other and causing errors in the communication. So that's why flow control happened. And why flow control is important, and that happens at the layer 2. Data link layer also responsible for access control. So when a single communication channel is shared by multiple devices, the MAC sub-layer of the data link layer helps to determine which device has control over the channel at a given time. So the access control will make sure which device would have the control over that channel in a given time, and that also happen at the data link layer. So remember, the network layer is for routing, data link layer for switching. Routing protocols use IP addresses. The data link switching layers protocols use MAC addresses, and the only time you will see a switch in the network layer is the layer 3 switches, which are more closer to the routers than to switches. Finally, the most bottom layer is the layer 1, which is the physical layer that provides access to cable, electrical signals that would be using ones and zeros, or it could be actually light signals as well, because if you are using fiber optics cables, so it's not just electrical signal, it could be light signal as well. And it is also define the standards for media, such as the cable type that you're using, such the Cat5, Cat6 cables, or the fiber optic cables, etc., etc. Those all defined in the standards of physical layer standards under the very bottom layer in the OSI model. So the functions of the physical layers can be described as bit synchronization. So the physical layer provides a synchronization of the bits by providing a clock. The clock controls both sender and receiver, thus providing synchronization at very bottom bit level. So it's very important operation, because that is basically synchronization of those bits, ones and zeros, which are the fundamental building blocks of computer engineering, computer systems, and network engineering, right? So the physical layer is responsible for synchronization of those bits. Bit rate control is also done by the physical layer, where the physical layer defines the transmission rate. So in other words, the number of bits that can be sent per second. So the bit rate is defined by the physical layer as well. It also defines the physical topologies. So the physical layer specifies the way in which different devices and nodes are arranged in a network. So if you hear network topology such as the bus topology, star topology, mesh topology, etc., those topologies are basically defined at the physical layer level. So that's how you know a topology is a mesh topology, because it is based on that physical layer standardization. A physical layer also responsible for transmission mode. It defines the way in which the data flows between the two connected devices or multiple devices. So the various transmission mode possible includes the simplex, half duplex, and full duplex. But as I mentioned before, the full duplex is the most commonly used type in 2024. So finally, here's a summary of the overall view or overall picture of the OSI model that we discussed today. The bottom layers, which includes the physical layer, data link layer, and the network layer, is associated with hardware layers. Remember, the physical layer, data link layer, and the network layer, what they do from my previous slides, they are typically associated with what we call the hardware layers. Then what we see in the middle, which is the transport layer, layer number 4, is responsible for transport of of the data. And then the top layers, which are the session layer, the presentation layer, and application layer, they are what we define as what we call a software layers. So this is a broad overview of how you can define or separate different layers in the OSI stack. When you are communicating between devices, let's say you have a computer and you're accessing a website, you typically go from top to bottom. So you go from application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer, and then that's how the communication typically happens. But when you're describing things, we typically go from bottom to the top. So we start from physical layer as the number 1 layer and the application layer as the number 7 layer. So here is a brief comparison again on the OSI and the TCP IP models, which I have done at the very beginning of this lecture as well. The OSI model divides the network access layer and the application layer of the TCP IP model into multiple layers, because you can see that the network layer and the application layer have been further subdivided in the OSI model. The TCP IP protocol suite does not specify which protocol to use when transmitting over a physical medium, but however, the OSI model does. The OSI layer 1 and 2 discuss the necessary procedures to access the media and the physical means to send data over a network. So those are the differences between the OSI model and the TCP IP model. Again, I will go over what this model means in terms of TCP IP in a separate lecture. So this is just the lecture focusing on the OSI model itself. So I hope you understand how OSI model works. If you like my videos, please thumbs up this video and subscribe to my channel. Good luck with your exams and have a nice day.